Welcome to solverfy.
Here we need the formula for a planet, and then we need the density of Earth. So we can say that the force of gravity would be the only force on any satellite, and this would be equal to the mass times the centripetal acceleration. So we can say that the gravitational constant times the mass of the satellite times the mass of Earth divided by r squared will be equal to mv squared over r. And so we can say that the velocity is going to be equal to the square root of g times the mass of the Earth divided by r. And this would be for the satellite. Now, we know that by definition, this will equal 2 pi r over the period t, and this is for any object under a uniform circular motion. We know that m over r cubed is simply going to be equal to 4 pi squared over gt squared. So essentially, we have said that the mass, we can actually define this mass of the Earth. So here the mass of the Earth divided by r cubed. We've essentially manipulated this and said that created a density function, essentially, and this is equaling 4 pi squared over gt squared. And so here we know that the density is going to be equal to the mass divided by 4 over 3 pi r cubed, given that we're modeling the Earth as a perfect sphere. And we can say that this is going to equal 3 over 4 pi times 4 pi squared over gt squared. So essentially we're plugging in for this m over r cubed function. So this term right here is being substituted in with this. And so we can finally say that after these cancel out, we have that the density is going to be equal to 3 pi over gt squared. And that's how we find the density of a planet, given that we only have a satellite in orbit. So the period of the satellite, so we can say that in this case, the period of the satellite is inversely proportional to the density of the planet. And this would be your answer for part A. And for part B, for Earth, we're simply going to solve it. So for Earth, we can say that the density of Earth, it'll be 3 pi, and then 6.67 times 10 to the negative 11th Newton meters squared per kilogram squared, gravitational constant, and then multiplied by 85 minutes, or we can say 60 seconds per minute, and quantity squared. And we find that the density of Earth is going to be equal to 5.4 times 10 to the third kilograms per cubic meter. So this is the final answer for part B. That is the end of the solution. Thank you for watching.